Okay, so big thing on this assignment has to do with significant digits. Okay, and I need everybody paying close attention for this. Counted numbers do not affect your significant digits because they are counted, not measured. Okay, so if you have a question that talks about, let's say, a pendulum oscillating back and forth 5 times, that isn't a number you measured, it's a number you counted. Counted numbers do not affect your significant digits. Okay, we talked about that a long, long time ago when we talked about significant digits, but it hasn't come up since then. Okay, so now it comes up again, so quick reminder, counted numbers are not measured values, thus they do not affect significant digits. Okay, for most of these, just don't overthink them, okay? Like, this is testing the following things. Okay, the things that affect the period of a simple harmonic oscillator, so a mass on a spring or a pendulum. Okay, there's a few questions that deal with those, right? This formula may come into play a few times, T equals 1 over F, okay, a couple of times in the assignment itself, okay? You may end up with a little bit of this here or there, okay, as well as, you know, sometimes those are equal, or sometimes the force of gravity is equal to that. And then obviously you've got some conservation of energy stuff, okay, where we have to remember that the potential energy could be gravitational if we're talking about a pendulum, or it could be elastic if we are talking about a mass on a spring. Okay, law of conservation of energy still applies. Okay, EI equals EF. Okay, like I say, most of these are not going to be terribly complex mathematically. There's one or two that are tricky contextually. Okay, I would say that number 4 is contextually a little bit tricky. Okay, because it's talking about 2 different pendulums in the same question. All right, you may have to use one to figure out something for the other. Okay, because there would be one thing that 2 pendulums oscillating side by side would share. Okay, okay, 1/6. Is that going to contribute to your significant digits? Fractions can't do that, right? Okay, so that one's not going to be there. Number 7. We do have to talk about number 7 because people mess up number 7 all the time because they don't read it carefully enough. Okay? When an object of mass m1 is hung on a vertical spring and set into simple harmonic motion, so it's like Hooke's stuff, right? It's hanging from the ceiling, it's oscillating up and down. Its frequency is 10 hertz. When another object of mass 2 is hung on the spring along with mass 1, so situation 1, only mass 1 is on the spring. Situation 2, both are on the spring. Okay, it's crucial that you understand that both masses are on the spring in situation 2. The frequency is only 5 hertz. Find the ratio between mass 1 and mass 2. All right, here's the tip I will give you. You don't have enough information to actually calculate the real masses in this question because you are not given the spring constant of this spring. But you are also not asked to calculate the real masses of these 2 situations, only the ratio between them. So you could calculate numbers that just represent the masses. There is one thing that is common to both situation 1 and situation 2. It's the same spring. Okay, that's as much as I can tell you though. That pretty much gives it away. Okay, without completely giving it away. It is the same spring, and you don't have to calculate the actual masses, just numbers that represent them to get the ratio between them. Okay? All right. Okay, Okay, watch out for ones that are asking for frequency. Sometimes people get to they calculate the period, then they forget, well, I got to go one more step and get the frequency. Okay, make sure, like on question number 9, okay, find the frequency, not the period. Okay, 12 and 13, make sure you observe this. These are only out of 3 marks. They are very, very simple calculations. Do not overthink them. Do not try to do more work than is necessary. At the very least, a conservation of energy problem would be 5 marks. Okay, these involve energy, but they're only out of 3 marks. So they may not involve conservation of energy. Okay? All right, that's about as much as I can give you without giving too much away. Okay, if you have questions while you're working on it, let me know, okay, and I will give you frustratingly cryptic answers, but at least it's something, okay, you can come and ask, okay. You got the rest of the class to work on it. I don't see why a lot of you won't be done, okay, by the end of class. I'll figure out a due date here while you guys are working, okay. Okay, guys, just so you know, due date for this is going to be January the 9th, okay. You got lots of time to get it done, and you'll probably even have it done today, but that's what I'm going to make it actually do for you to hand in. If you want to hand it in before that, that's totally fine. Okay, but that's the day it has to be handed in.